ilk oturumu konuşmacıları ve oturum başkanları şu anda karşınızda. Ben sözü Sayın Profesör Serkan Mısır'a bırakıyorum.
Hocam çok teşekkür ederim. Tekrar hoş geldiniz 16. Prefabrik Sempozyumuna. Umarım verimli bir toplantı olacak bugün. Dekan hocamız da ve önceki konuşmacılar da çok kıymetli görüşlerini dile getirdiler. Bu oturumda 3 tane konuşmacımız var. Zamanı iyi kullanmak adına direkt onlara geçmek istiyorum. İlk konuşmacımız Prof. Doktor Yuji Ishikawa. Kendisi Japonya'daki Shibaro Üniversitesi Teknolojik Fakültesi'nde yapı mühendisliği alanında profesör olarak görev yapmakta. Çalışmaları özellikle prefabrik ve yüksek dayanımlı beton sistemlerin deprem performansı, kiriş kolon bağlantı detayları ve çelik fiber takviyeli beton uygulamaları üzerine yoğunlaşmaktadır. Prefabrik beton elemanların sismik davranışı konusunda çok sayıda deneysel ve analitik çalışması bulunan Profesör Ishikawa, Japonya'daki modern prefabrik yapı teknolojilerinin gelişiminde önemli katkılar sağlamıştır. Sözü Sayın Ishikawa'ya bırakıyorum.
Thank you, Chairman. It's honor for me to invite this excellent symposium in Turkey. Today, I show the historical technologies trend in precast reinforced concrete structures in Japan. Today, I introduce historical and technical trend in precast reinforced concrete structure in Japan. Firstly, I would like to show the introductions. This is first our lessons of seismic disaster in Japan. The Great Kanto earthquake occurred in 1923. The Ryonkak Tower and surrounding unreinforcement masonry buildings and wooden buildings suffered severe collapse and immediately after fire damage, so huge. And a seismic record by Professor Imamura, the record shows the Kanto Great Earthquake more than they are expected. And this is the actual conditions after the Kanto Great Earthquake. So many buildings collapsed, and also fire disaster occurred like this. As a result, our lessons afterward, Japan have to make the building standard law its particular point to compare with overseas. Please see the slide. The slide shows a graphical future of Japan. Japan sits on the four tectonic plate like this. As you know, in Japan, we have always surrounded earthquake like this. Chapter 2 explains the original precast concrete in Japan. Please see the slide. In 1940s, Dr. Heigak Tanabe proposed the precon, the structure made by concrete to be reinforced fire protections by means of the traditional wooden structural image like this. And this is an example of the Japanese wooden structures. Nevertheless, wooden brace system was proposed Josiah Kondo after Nobu earthquake. Section 3 explains the history of precast reinforced concrete construction in low or middle-rise housing. This slide shows standard houses of complex, which was assumed a household of 4 or 5 members and included a bathroom and kitchen within the floor area of the 12 or 13th tubo. Tubo means equal to 3.3 square meters, very small, to supply huge houses for workers' families after World Wars. And this slide shows the first precast system for complex in 1915. The tilt-up method, wall and floor panel were divided into flat sections, and concrete was cast in layer on the horizontal casting bed to produce precast element. And this slide shows the joint of the precast panels. The method on-site or welding of steel connectors or by casting concrete like this. After that, the 4-story wall-type structures was proposed using a precast panel. The precast system applied on-site or welding of steel component and mortar strip joint. You can see this one. Sorry, I couldn't. This slide shows the wall-type precast concrete construction method and factory's image like this. Gradually advanced precast technologies in Japan. The slide shows the middle-rise wall-type precast concrete construction method, of which target is until 8 stories in 1970s, like this. Turn to the 1988, Takina Corporation proposed high-rise wall-type buildings. The method is applied cast in place. Nevertheless, the proposed a residential room without any projection of the columns sections. The point have big merit for architectural planning in Japan. After that, high-rise wall-type precast concrete construction method was researched, collaborated by government facilities and private construction companies. In 1990s, they did this project like this. And this slide shows the RPC method. This method is moment frame precast reinforced concrete. In 1990s, mainly columns longitudinal bars are jointed using a mortar strip joint, and building was constructed in Makuhari as a new urban city by Housing and Urban Development Corporations. It's government facilities. Turn to the section 4. Section 4 explains the background factor driving the advancement of precast concrete technologies in Japan. In 1964, Tokyo Olympics was held. The big event demolished 31-meter high regulations to build in Japan to build international hotel. And in 1972, Shinamachi apartment was constructed as the first high-rise RC buildings, of which height is 48.9 meter, with specified concrete strength is 13 megapascal concrete. Because nevertheless, the project could not apply the precast system because we don't have the large crane and advanced precast technologies. We could not do that. In 1980s, Japan Housing Corporation was renamed Housing and Urban Development Corporations and promoted to build high-rise RC buildings in Hikarigaoka complex. Nevertheless, this project was not applied precast technologies. But actual construction technologies gradually advanced. I will show the historical trend of high-rise RC buildings in Japan. The graph shows the transition of number of high-rise RC buildings in Japan. Today, I could not much time to explain detail. Afterward, please check my papers. I would like to introduce the new RC project. New RC project starts from 1988 to 1993. The project was industry, government, academia, collaborative, a big research project, and to realize high-rise RC buildings using high-strength concrete, high-strength steel bars. Section 5 explains development history of precast concrete system in Japan after New RC National Research Project. The project is the first time to build over 15 stories of high-rise RC buildings in Japan. The project is applied large-scale on-site precast construction method in 2000. Firstly, please see this slide. The construction site make the same condition of the ground levels to make the precast beams. Before casting concrete, beams, longitudinal bars jointed using a screwed joint and slip joint for steel bars. This picture shows after casting concrete of precast beams. You can see the screwed rebars couplers, which was connected on construction floors. After that, the picture shows the actual construction floors conditions. And this is a precast system like this. Beam column joint casting. Nevertheless, this method applies the precast column, precast beams like this. And the technologies realized 5 or 6 days tacked during the constructions for high-rise RC buildings. And please see, I described the precast concrete columns. The project tried to fabricate 100 megapascal high-strength concrete, precast concrete columns on site. This picture shows the condition of the prefabricated RC columns. Left side shows the before casting. You can see the slip joint for longitudinal bars joint. And right side shows the after casting 1-day cycle for manufacturers high-strength concrete columns using 100 megapascal concrete. And after that, we lift up the precast column on construction floors like this. And this slide shows the merit of slip joint. we used the splice strip joint system. And please see this video. This video explains the splice strip joint. It's a mortar strip joint. This video quoted by a splice strip joint.
With its original non-metallic grout, self-sealing
And also
valve,
some
stoppers with indicator, and electric
Turkish
pump, mass
company
driving can be
applies
performed.
these technologies. Someone who knows this method, but I would like to introduce these technologies. This technology is has high reliability in Japan.
The non-metallic standard SS motor or
And
high
also
strength
this
SS motor 120 Newton,
system
equivalent to almost
are able
18,000
to apply
PSI,
the
can be
high
pumped from
strength
an inlet
concrete
or
materials,
joint gap and
more
run to
than
all sleeves one time.
200 megapascal or 150. Splice strip joint has a high strength mortar.
First perimeter seal for joint gap is set with SS mortar with less water contents.
This
air
method
tube,
is a
or
little
wood
bit
frame.
particular point. To check easier, fill up the mortar. And we have to test for looking about joint. This slide shows the test result shows. And also, we have to do that before starting the project. We did the precast concrete columns seismic test like this. At that time, I worked in Takenaka Corporations. I did this project, and also I did the experiment test like this to check the equal to precast column have the more than good performance casting concrete columns. And this slide shows New Zealand famous professor proposed new technologies. I think this idea was influenced in Japan, I think. And also New Zealand applies this method. This method is precast beam and precast beam column joint like this. But this building was damaged in 2011 Christchurch earthquake. Now the building is demolished. I would like to see the thing of the project Park City Musashikosugi, which has 59-story and 47-story high-rise RC buildings. The project was highest RC high-rise RC buildings in Japan at that time, around 2006. This slide shows the advanced precast concrete construction system. Yeah, monolithic joint integrated precast connections method like this. A little bit advanced technologies to compare with previous method. And this slide shows precast unit was fabricated at factory Tokyo suburb areas. And midnight, this precast carry on construction site, and early morning pick up the precast parts and assembled the precast unit like this. And please see this construction floors. I think very clean. Prekast merit is very clean. It is possible to keep the clean on construction site like this. And clean condition is keep the safety and high qualities. I think so. And this is this slide shows how to joint precast monolithic joint integrate precast parts like this. You can see a few workers, 2 workers and 1 supervisors, only 3. Very small numbers of the workers. And I think this method is very good method for high-rise RC buildings. And this is another type. This type is full model, full precast type, advanced technologies, but a little bit difficult. It is hard to check the by one eyes, fill up the mortar or another point, but this method is very excellent. And this method applies this project. This project is as a Dai Hills residential tower B. This building is highest buildings at present, of which height is over 260 meters. And I turn to another distinctive precast construction method in Japan. This project is Suita Football Stadium in Japan. The project applies several precast systems in 2015. Firstly, I introduce precast footing system and precast press-rest concrete beams for audience seat supporting the very long beams like this. And also, this is a high-strength steel fiber reinforced concrete slim car. This photo shows under constructing. This is a finished condition. The column applies to 100 MPa high-strength concrete with steel fiber and high-strength steel bars like this. And this is another particular project. It's unique high-rise RC buildings. This slide shows the structural perspective drawing. The buildings is 3 wings, and nevertheless, the buildings is applied base isolation system, also with damper on the sky gardens. This slide shows the main frame of the buildings, and each wing's construction cycle. This slide shows a 6 days construction cycle for each wings using precast columns and beams like this. And the building have 3 wings. Each wings is difficult construction cycle to keep working for each workers are able to work every day on the site. I would like to introduce this project. This is the latest project. The building's height is over 220 meters, and the project owner, Moribiro, want to keep no damage condition after earthquake for residentials. Contractors and also structural designer was Takinaka Corporations. Takinaka Corporations engineering values proposed using a steel fiber reinforced concrete structures. As a result, the project applied steel fiber reinforced concrete structure. High-strength steel fiber reinforced concrete was applied until 13 stories or columns. It's first time to apply the volumetric ratio 1.0, very high percentage of steel fiber reinforced to reduce the damage and to get the good performance. We did experiment test to consider the merit of high strength steel fiber reinforced concrete. This slide shows the experimental test to verify the excellent performance high strength steel fiber reinforced concrete structures. You can see the graph. Graph shows the vertical axis shows the shear force, horizontal axis shows the drift angle. One is normal high strength concrete, and another one is 0.5 volumetric ratio high strength steel fiber concrete columns, and blue one is 1.0 volumetric ratio high strength steel fiber reinforced concrete structures columns. This project applies the blue lines. We get the good performance and this is a summary. My English is not that good, but I would like to introduce this position. Yesterday, I saw so many RC buildings, high-rise houses, and office. Turkish has good technologies, but now left side shows overseas disasters. Japan, we need the reverse connections. It's very important for precast concrete structures. I think so. And finally, a little bit old time, but 2011, we gratefully appreciate Republic Turkey supported after Great Tohoku earthquake and tsunami. Thank you so much.